Electrical circuit solution by PSPICE program with the dependent sources. You know, the four different sources: voltage control voltage source, voltage control current source, current control voltage source, current control current source. Like these four dependent sources are there. No? So from these four different sources, by taking one example, that is called current dependent voltage source and current controlled current source. Okay, current controlled voltage source, current controlled current source. In this circuit, it is having two dependent sources. First one is called current controlled voltage source and current controlled current source. This dependent source is depends upon current flowing to the R2, and this dependent source is depends upon current flowing to the VS. Current flowing to the VS. Understood? So this dependent source, voltage controlled current source is current controlled voltage source is depends upon current flowing to the R2 ohm resistor, and current controlled current source is depends upon voltage source Vs, that is called I naught here. The I naught is connected here across the Vs, and I2 is connected across the current flowing to the R2. Okay, current controlled current source of 0.5 I naught. We are required to find all the voltages and currents, node voltages and currents. How to write the program in the circuit to find the all node voltages and currents, and also across the R2 Thevenin's equivalent circuit, and also find the Thevenin's equivalence across the R2. This R2 resistance. This can be written like this. From this next, this can be drawn like this. Okay, in this way we have to draw the circuit diagram. Redraw the circuit diagram. So this is the original circuit diagram. This circuit diagram can be drawn like this. Okay, understood? So how means here we need to find the Thevenin's equivalent across this R2 resistor. That's why, so we have to draw the circuit numbers with numbers. Here first one, this is called ground reference 0, 0, and here indicate 1 and 2 and 3, and here introduce one dummy source Vx, and this voltage source is called 0 volts, and then current flow into the dummy source Vx is called I2. So Vx is equal to 0 means it's short circuit, no changes in, no effects in main circuits. The main circuit is not disturbed. This, as it is, no changes in the main circuit by introducing the Vx is equal to 0 volts. Okay. And here 0.5 into I naught. I naught is depends upon current flowing to the voltage source. That's why dummy voltage source is not required. But here dummy voltage source is required because of this current is depends upon current 2I2. No? I2 is depends upon current flowing to the this branch R2. That's why dummy voltage source is required to write program dot print I of Vx. Okay, to write I of Vx in program, to write I of Vx, here I of Vs, to write I of Vx that automatically we will get. Here to write I of Vx, we have to write we introduce one dummy voltage source. Understood? Then how to write the program? So like this, how to write the program means in this way. So first one, voltage source Vs is connected between 1 and 0. 1 and 0, how much? 6 volts. Voltage source is connected between 1 and 0. Vs 10 DC 6 volts. Vs 10 DC. This is called DC source, and then 6 volts. The next Is, where is Is? This is called Is. Is connected between 4 and 0. 40 DC 1 amps. Okay, that's why we have to write like this: 1 amps. DC 1 amps. DC current source. It's connected between 4 and 0. DC 1 amps. 4 and 0. 4 zeros. 4 space 0. DC 1 amps. The next R1 is connected between 1 and 2. So that's why 1 space 2 space 100 ohms. Then similarly R2 is connected here 2 and 3, and 2 and 3 like this 1K, 1 kilo ohms. Then Vx is connected between 3 and 4. Vx 3 and 4 DC 0 volts. And then F1 is connected between 2 and 0. F1 0 2 or 0 2. The current direction is upward, that's why 0 2, right? 0 2. F1 is 0 2 and it depends upon current flowing to the source voltage. That's why Vs. And gain is called 0.5. Like this, we have to write. This is the main important concept. How to write F1 source. This dependence, current controlled current sources. In PSPICE, the name is given as PF. The name is given as F. That's why we have to write the program. F1 is connected between 0 and 2. F1 is connected between 0 and 2. And it depends upon Vs. And gain is called 0.5. Like this, we can write. F1 is connected between 0 and 2. And it depends upon Vs. And gain is called 0.5. Then similarly, H1 is connected between 1 and 2. H1 is connected between H source, that is called current dependent voltage source is connected between 1 and 2. In this bit, in between these two, this H source dependent source is present. That's why H1 is connected between 1 and 2. And it depends upon current flow into the Vx. Vx is equal to 0. That's why short circuit. And that is called I2. So H1 is connected between 1 and 2. And this depends upon Vx. And gain is called 2. Like this. H1 is connected between 1 and 2. And it is a Vx. And depends upon Vx. And then gain is 2. Then that print DC, I of R1, I of R2. To find the current flowing to the R1 resistor and current flowing to the R2 resistor, we have to write like this. Dot print DC, I of R1 and I of R2. And then similarly, dot print DC to find the node voltages. Here we have 1, we have 2, we have 3, we have 4. So like this, we have to write the program. Dot print DC, we have 1, we have 2, we have 3, we have 4. And then next, here this question is called also find a Thevenin's equivalent circuit across R2. That's why we have to write dot TF transfer function. We have 2, 3 here. Here we have to write the open circuit voltage and Thevenin's resistance. To find the Thevenin's resistance across the 2 and 3, we have to write like this. Dot TF. We have 2, 3 Vs. Output by input. We have 2, 3 Vs. Output resistance. So here, this is the load is connected across the 2 and 3 terminals. That's why we have to write program dot TF. We have 2, 3 space Vs and then dot N. So in this way, we have to write the program and then we will get the results like this at node 1 voltage, node 2 voltage, node 3 voltage, node 4 voltages. Node 1 is called 6 volts, node 2 is called 4 volts, node 3 minus 996, node 4 minus 996, like this. These are the node voltages. And then next node source currents, voltage source currents. So Vs, voltage across the Vs, current flowing to the Vs and current flowing to the Vx. Current flowing to the Vs is called, that is called I0. I0 is nothing but minus 2 amps. This is called current minus 2 amps. And then current flowing to the Vx. Current flowing to the Vx is called, this current flowing to the Vx is called I2. That is equal to 1 amps. In this way, we have to find the voltage currents. Current flowing to the name is called Vs. Vs is called, current flowing to the Vs is called I0. I0 is equal to minus 2 amps. And then Vx is called current flowing to the R2 resistor, that is called I2, is nothing but 1 amps. And then next, so the program written like this, dot T of V comma 2, V of 2, 3 Vs, that is called Thevenin's equivalent circuit across R2. That's why we will get like this. V of 2, 3 divided by Vs, that is called transfer function, is nothing but 1 to e power minus 10 to the power of minus 9. Exponential is minus 9. That is called input resistance at Vs is called, from input side resistance Vs is nothing but 2.5 into e 10 to the power of 11. And then output resistance at V of 2, 3 at 2, 3 branch. Output resistance is nothing but 1 into e power 10 to the power of 3. That is called 1K. So like this, we can find the output resistance and input resistance by using this command V of 2, 3 Vs dot TF V of 2, 3 in this way. By writing the list like this, we will get the Yes, yes. Then next, how to simulate this, how to write the program in PSPICE. Open PSPICE AD student. PSPICE AD student, right here. PSPICE AD student. PSPICE AD student. PSPICE AD student. Like this. PSPICE AD students open and go to file, new text file. Okay, open PSPICE aid student first. Then after that, go to file and new text file like this. First write here title, simulation of simulation of simulation of DC circuit with the dependent sources, with the dependent sources. First line compulsory text. This line is called only for text only. Don't start program from here onwards. It is only for text to write the title of the program. Okay. The next start here from here onwards. What is the voltage here? VS10 DC 6 volts. Right here. VS10 DC 6 volts. Like this. The next IS40 DC 1 amps. IS40 DC 1 amps. Okay. Next R1 1200. R1 1200. R1 1200. Okay. Like this, write the program. Like this, write the program. VS10 DC 6 volts, IS40 DC 1 amps, R1 1200, R2231K, VX434 DC 0 volts, F10 2 VS 0.5, H112 VX 2 amp 2, dot printed DC I of R1, I of R2, dot printed DC V of 1, V of 2, V of 3, V of 4, and then dot TF V of 2, 3 VS dot N. Okay, and then go to file and save as Thevenins. Okay, Thevenins, and right here circuit file is called CIR in the form of CIR dot CIR dot CIR, only save in the form of CIR only. Circuit file save as type as nothing but CIR, circuit file CR, then only you will get uh, program can be simulated or can be run, can be executed. Otherwise, not possible to execute and then save. Okay. So from this here, open. Here, this open icon is there. Na? Press open icon right here. Select here. File tab is nothing but CIR. 1, 2, 3, Thevenins CIR. That's file name is given like this. Okay, open in this way. And then when it is open on this icon, Thevenins file name, and then this is called run icon. Press run. And then if it is not having any errors, directly we will get the results here. This is our results. Okay. Here we will get the results from this. I can understand from here. So this is first is called program. First, this is called program, and then this is called simulation results. Node voltages. Node 1, 6.00. Node 1, and then voltage. Node 2, voltage. Node 3, voltage. Node 4, voltage. Like this, it will be displayed. And also voltage source currents. So voltage across the VS that is called I naught. That is nothing but minus 2 amps. And voltage across the Vx, that is called I2. That is nothing but 1 amps. Okay, e power 0, e nothing but 10 to the power of exponential. And then next, what is the input resistance at Vs is called 2.5 into 10 to the power of 11. Then next output resistance at we have 2 comma 3, there is nothing but across the R2 resistor is nothing but 1 kilos, 1 into 10 to the power of 3. So like this we can simulate by using program, PSPICE program. Okay, that's it.